Hey guys, let's talk about two very important terminologies, that is direction ratios and direction cosines. These are the parameters which will define or which will distinguish or differentiate between two vectors. It's really important to understand this. Let's go ahead and try to understand what direction ratios are. I would not teach you in any textbook language or definitions. It's a more layman language and more simple common sense to understand what direction ratios are. Let's go ahead, guys. Well, guys, I can see here there are three vectors, vector OA and vector AB, and we have another vector which is IJ. Now, what is the difference between these three vectors? Question: how do I say that they are three different vectors? Or can I say that vector OA is actually equal to vector AB? And what are the conditions to say that? One of them is direction ratios. Now, before I go ahead and talk about this, let's talk about what exactly are direction ratios for us. Well, to understand this, guys, I just give you simple conditions now. I tell you that you're at the point O now and you're supposed to go at the point A. But I'm restricting you, or the only condition is that you can only travel in the x-axis direction and the y-axis direction and the z-axis direction. You cannot travel in any other direction. And I want you to reach the point A starting from the point O. So that is exactly what you're supposed to do. Alright guys, let's say you start from the point O and you start moving from the point O like this. Now where are you reaching? You're actually traveling only in the x-axis direction. Look at that. And now you cannot travel. You just stop traveling because you cannot move ahead from here. If you go off like this, you're supposed to reach the point A with the shortest distance. So you could travel this much. That makes sense. Now what happens? You're standing here and now you want to travel to the point, this point basically. But now you need to change the direction. You maybe have to travel in the y-axis direction. Let's see how you do that. Alright. Now you start walking from here and you're moving 1, 2, and 3 units. Look at that. You move 3 units in the y-axis direction. Now again, you cannot reach the point A by traveling in x or y direction now, right? You have to go up like that. Look at this. You have to go up now. Now what you have to do is now you can travel in this direction, that is z-axis direction. So how do you do that? Look at that. You're moving in this direction now. Finally, you could reach the point A. Look at this. In this whole process, what did you just do? You traveled 3 distances. You traveled this distance, which is 2 units here. You traveled this distance, which is 3 units here. And you traveled this distance, which is 2 units again. Then I can say that the direction ratios of this vector OA, alright, the vector OA are nothing but 2, 3, 2. Alright, and surprisingly, I can say that its coordinates are all the same thing, right? And it is basically the position vector of the point A. So I can say that if I have to write position vector of A, I can write it as 2i plus 3j plus 2k, right? It means it moved 2i in the x-axis direction because this guy is I. Unit vector in the x-axis is I. So it is I plus I is 2i. It's like that. I can write the vector OA, position vector OA like this, and the x and the y and the z components are itself the direction ratios of a position vector, not a vector which is joining the point A and B. Now we'll understand this a little later. Now right now we understand how to write the direction ratios of a position vector. Position vector is that vector whose initial point is the origin and terminal point is any point in the space. We got it, guys. Well guys, can we apply the same logic to find the direction ratios of the vector AB now? Let's look at that. Vector AB is not starting from the origin. It starts from the point A here and has to go to the point B. Condition is same, they can only travel in the x and the y and the z axis. Alright guys, let's start from the point A and see how we can move ahead with this. I can say that is the point A and I'm moving from the point A in the x-axis direction. Look at that. I moved how many units? I can say 2 units in the x-axis direction. Fine. Now I cannot move anywhere else in this direction because I would have to go to the point B with the shortest distance. So I have to now travel in the y-axis direction. So that is this direction basically. Alright, so how will I do that is the question. Let's say I start moving from this point now and I'm traveling how many units? Look at that. I'm traveling 3 units in the y-axis direction. Alright. I cannot go further because if I go further, I would actually miss the point B, the shortest distance. So now I am done with x and the y-axis direction. Now I have to travel in the z-axis direction to reach the point B. So that's a simple condition, guys. Now how will I do that is the question. It's pretty simple. I start from the point, this point where I stopped, and I reach the point B. Now I can see to reach the point B from the point A, I just had to do 3 things. I had to travel these 3 distances. I had to travel this distance from here to here, which is 2 units. from here to here, which is 3 units. Then again, I had to travel this thing, which is nothing but 2 units. So I can say that the direction ratios of this vector, I can write the direction ratios of the vector AB are what? It means I travel 2 units at 2 and 3 and 2. Look at that. These are the direction ratios of this vector. So guys, we got what exactly are the direction ratios of the vector AB, right? Where I can see that A is not the origin and AB is some vector. Now, what exactly are these guys? It is nothing but the distance traveled in the x-axis, and the y-axis, and the z-axis direction. So they are nothing but 2, 3, 2, and these are my direction ratios. Now, if I ask you, look at this, the direction ratios of this are same as the direction ratios of this vector. Can I say that these two vectors are equal? Of course, yes. You know why? Because it traveled the same distance. It traveled 2 units here, it traveled 2 units here. Then it traveled 3 units like that, it traveled 3 units like that. Then it had to go up with 2 units, and it also went up with 2 units. So it means these two vectors have the same direction ratios, 2, 3, 2. Yes, this makes these two vectors equal vectors or parallel vectors. All right, keep that in mind. Now I can say equal, why? Because their length is also same and the direction is same, and direction ratios are exactly equal. So I can say these two are equal vectors. That is, vector OA is actually equal to the vector AB, because their direction ratios are same. Now let's see how to write the direction ratios of the vector ij. For that, I should start from the point I and I should reach j, but I can only travel in 3 directions, x, y, and z directions, and those are nothing but your direction ratios. Let's see that. So I start my journey from the point I, and I can see that I'm moving towards the point j, but I'm only traveling in the x-axis direction. I'm not traveling anywhere else. Okay, so I cannot travel more now. I have to stop here. And from here, what should I do? Then I should travel in the y-axis direction. So let's see how to do that, guys. Now I can start from here. I'm moving in this direction. Yes, I can say I am moving here and I would be reaching this point. Okay, now what to do is a question. To go to the point J, I need to still travel one more distance, but in the z-axis direction. So I can say this is what I'm looking for. And right now I'm going up like that. So what are the direction ratios of this vector ij? Very interesting, guys. So if I see very carefully, I travel how many units here? I travel 3 units here, from -1 to -4. So that is -3. Okay, so the direction ratios are -3, comma. Then I move this distance, so I can say very clearly, I can see this is the distance I moved in the y-axis direction. Yeah, this guy is nothing but 2 units. So I can write I moved 2 units in the y-axis direction. Then I had to move what? I had to move 1 unit here in the z-axis direction. Then I can say yes, this guy is nothing but 1. So these are the direction ratios of the vector ij. Okay. Alright, guys, now let's talk about how do we do this whole thing mathematically. How do I write the direction ratios of a point? Okay, let's suppose that is the axis I have. That's a point O, which is the origin. I have a point A here. Now I can see in the graphic diagram also, I'm talking about the point 2, 3, 2. These are nothing but the coordinates of the point A. Now, for a position vector, it means its initial point is O and its final point is A. I can write the direction ratios very, very simple. They are as good as its coordinates. So direction ratios are nothing but 2, 3, 2. And if I have to write the vector, I write it as OA, which is called as a position vector, which is nothing but 2i plus 3j plus 2k. So that's all about the position vector, guys. Now what happens if I have 2 points in the plane? So let's say that is what I have. So we have a point A here and a point B. I can see in this case I have the point A as 4, 1, 2. Let me take the point here. That's 4, 1, 2. And at the point B somewhere here. And that guy is the vector AB. And the point B is 6, 4, 4. So how would I find the position vector of, let's say, the point AB is the question. So that's pretty simple, guys. I take this to be x1, y1, and z1. And these 3 guys as x2, y2, and z2. So these are nothing but the coordinates of the point A and B. To find the direction, okay, I'll just to find the direction ratios of what, the vector AB, I have to do a very simple thing, that is x2 minus x1. Alright, comma y2 minus y1, and I can write z2 minus z1. So these are the direction ratios of the vector AB. Now I can see here in the graphic diagram that x1 is 4 and y1 is 1 and x2. So this is the guys basically, right? So if I have to write the direction ratios, x2 is this guy, that is 6 minus 4. Then you have, I have 4 minus 1, that is 4 minus 1, and then you have 4 minus 2. So 4 minus 2. So these are the direction ratios of the vector AB. I can go with this. This guy is 2, 3, 2. I can see these are the exact direction ratios in the graphic diagram also. This is what I'm talking about. These are the direction ratios of the vector AB. Beautiful, guys. This is how we do it mathematically. Very easy. We just had to visualize this so we can understand. That's it, guys.